Hi, good afternoon, folks. This week, I'm going to talk about a couple of topics that really don't fit in with sort of most of the other sort of individual pieces in the class. So it's not sort of directly related to a game or to a specific sort of programming technique or something like that. But it's something that is certainly worth knowing about and will probably hopefully reduce sort of headaches when you have to do this yourself. So today is some post-processing with the universal render pipeline. And then on Thursday, we'll be just talking about a bunch of the settings and what you need to do when you import certain types of art. So let's say you have a tile map. You used a pixel-based drawing program, and you created an awesome tile map for some sort of tile-based game, and you want to make sure that that's imported correctly, and all the tiles are individual sprites, and Unity didn't automatically blur your stuff so that the pixel sort of nature of it is all destroyed. You want to make sure that those settings are correct. So we'll look at 2D sort of versions of that as well as 3D. So I'll show you some of the 3D stuff too. These are things that, of course, you can go online and sort of look up, but I sort of wanted to put them in sort of an individual place, sort of a single lecture that sort of had all those pieces to it, or at least the important ones. We have one more game that we're going to make. There likely won't be an assignment on this one. I haven't really decided, but if we did, it would sort of overlap with the sort of Game Jam final project. So there likely won't be. The game itself is still relatively simple, but we're going to use things like a factory pattern, and we'll have a couple of state machines, one for the boss, one for the game. We'll have some enemies that use some movement AI. So it's going to be a whole bunch of pieces together that will give us a lot of flexibility. So you'll see a more complex sort of designed game in action in Unity, how those pieces fit together along with the Unity engine that can sort of make this game work properly. So we have Thanksgiving in there as well, which is only one lecture that week. So we might not get exactly 3 weeks worth of stuff out of it, but that's sort of the plan for the next game after this week. We are going to create a universal render pipeline project today. I sort of have a lecture or have a project already set up for this, but I'm not going to use it today. So the main thing that we need today for creation of a project is a new one, but not a 3D one, a universal render pipeline project. So I'm just going to name this like URP Post-Process or something, lecture, whatever, whatever you want to name it. So it'll be a universal render pipeline one. I will load up an HDRP one later today, so that would be like the shader graph lecture one. I'll probably just load that one up. But I do want to make one of these so I can show you not only the post-processing stuff, but what happens when you create one of these sort of from scratch. It includes a bunch of stuff with it, and so we're going to sort of get rid of some of that stuff. So universal render pipeline project, name it whatever you want to, and we'll do create. It will take a little bit to completely load up, so that's why I'm doing it now. Along with the lecture slides on Blackboard, there is also a quick movement script. There's sort of nothing special in here, but if you want to download it and be ready to drag that into your project, that's something that we'll need sort of at the end. We don't need it at the beginning, but at the end it will be useful for us to have when we look at local post-processing volumes. So back to the slides. Post-processing is, if you sort of don't know exactly what it means, when you go into your settings for a video game and you see things like anti-aliasing, and you can change that, none or 2x, 4x, whatever, and ambient occlusion and motion blur and depth of field, and all of those sort of options, maybe in like an advanced options screen or something sort of associated with where you might find anti-aliasing at. Those are typically post-processing options. So our game engine, Unity, and basically any game engine that you use, will render your 2D objects or 3D objects to the screen. That render is going to put the materials on them. It's going to figure out sort of how to do stuff with the lighting and going to render stuff sort of decently. Post-processing gives you an extra layer of image effects beyond what was just rendered. So even things like color correction. So maybe your color All right, I am back, folks. My Windows tends to not be great these days because I have a few things going on for. Check my camera here as well. So we may not. I may not have the camera at the moment. Let me just try again. Yeah, so I've been doing stuff with GPU programming, and Windows has been not too happy with that recently. And it could be partially due to my camera as well. Looks like we may not get the camera back until I restart. Okay, in any case, yeah, so I'm reopening that that project again. I'm not sure exactly where it sort of cut me off at, so I will sort of go back through a little bit of this. I don't expect today to be sort of too long. There's not sort of a ton to talk about. It's just showing off some of the stuff that you can do in the sort of post-processing pipeline. All right, so that sort of extra layer of stuff that you do. Yeah, so that sort of extra layer of stuff that you do to your final image is what post-processing is all about. So adding things like bloom to a very sort of highly lit area, or the like sort of the last thing I said before I got kicked, the sort of color correction or a lens flare, things like that, extra things that you would add into your image to essentially enhance the way it looks or change the feel of what it looks like. You see this all the time in TV shows and movies. When you sort of look at behind the scenes stuff, all of the lighting looks more or less normal, but then when they show you what they do in the final product, you see things like stuff looks a lot darker or stuff is a lot bluer, for example. That's post-processing. They're taking whatever comes out of the camera in the case of movies and messing around with it, changing certain properties of it. So that's something that we can do as well. It depends on the render pipeline we're using. So we're going to look at URP, but in the HDRP, there is even more options about sort of messing around with some of these things, like motion blur and fog and stuff like that is sort of all part of this as well. In the end, you're just looking for more pleasing visuals. That's really sort of what we're going for. So an example of this is anti-aliasing. It's very common. It basically smooths out sort of jaggies that you get from the rendering. Because when we render, it's not a continuous, it's not sort of a continuous image. We have pixels, and we have to put colors in those pixels. And so depending on the resolution of your monitor, depending on the resolution of textures, you're going to get stuff that looks like, put my little annotation stuff here, you're going to get things that look a little jagged, and this is just a result of the rendering process. What color do you put here? The graphics engine is going to figure it out, but you might see some sort of jaggedy type stuff. And there's a whole, you could do a whole thing on sort of exactly why aliasing comes about. Well, what anti-aliasing does is, and it depends on what version of anti-aliasing you're using, exactly how it works, but typically those areas where you get these jaggies are rendered more than once. And then there's some smoothing that's applied. So you get a much smoother looking, potentially blurry looking, it depends on the version of anti-aliasing you're using, but you get a much smoother looking sort of end result. That's post-processing. That's something that has happened sort of after you render the original image, then you sort of go over it again and try to smooth out those jaggies, either render some of it again or use some other algorithm on the sort of jaggy parts to try to smooth them. That's why if you turn up anti-aliasing, you get a performance decrease. So most of these post-processing effects will decrease performance. So on your phone, you're not going to use ambient occlusion and screen space reflections and bloom and tone mapping and temporal anti-aliasing and all of these options. You're not going to use those because it'd be too much for the phone to process currently. So most of the heavy post-processing is for high-end systems. But in the URP, which is meant for either lower-end systems or lower-end sort of style graphics, you can do some good good post-processing effects like decent anti-aliasing, good bloom, all of those things, but still be able to do these on phones and lower end systems, for example. So we're going to look at URP today and what it can do, and then I'll just sort of show off a little bit about the additions that the HDRP adds to these things. The process to do all of it is typically the same. Yeah, so keep in mind, any post-processing will have a performance cost, always. All right, so the universal render pipeline is one of the built-in renderers for Unity's scriptable render pipeline. Unity sort of made it this way so that if you have other requirements for how you want to render things, you can actually write your own. But Unity sort of gives you two that fit into their scriptable render pipeline, the URP and the HDRP. Now, I'm basically lying here because I actually went back and checked today. This is actually not true. It should have been. I don't know why I didn't go back and do the conversion of our projects that I gave you, but I suppose in the future all the projects will be URP, but I don't think they actually are right now. So that's why instead of just going into one of the older projects, we sort of made our own URP sort of blank project. So we're not going to get into the weeds on how any of this stuff works. I don't know fully how all of the scriptable render pipeline works. It's something that I never got into, sort of rendering 3D graphics and stuff. One of the websites that I put on the syllabus, the Cat-like Coding, they actually have a whole set of tutorials about the scriptable render pipeline and how you can actually create your own render pipeline, starting with how do you draw an object? Like how do you draw a sphere onto the screen? And then going all the way to things like lighting and post-processing and sort of through all of these different aspects. So there is some good resources out there. Yeah, so the Unity project that we're going to use today, so whichever URP, whatever you named it, the one that we open up, we'll use that for today and for next time as well. We'll just load up 3D objects and stuff in that one as well. So essentially, we're going to be playing around with the post-processing stack today. All right, so I think my project should be loaded. Yeah. So this is what I get when I just load up a URP. So I just brand new universal render pipeline project. Notice that it already has stuff in here. So this is something that it's sort of showing off what the URP can do. That's basically what this scene is. So I don't want to use this. We're just going to do something very simple with a sphere, and we're going to make some post-processing volumes and stuff and sort of see what you can do. So essentially, this scene, we're basically not even going to use it. There is stuff in the assets that you can delete as well, but for now, I'm going to open up the scenes folder, and I'm going to create a new scene. And I'm just going to name this, I don't know, I'm just going to name it main. And let me turn on pen attention here. Get my little green pointer. Okay, so I just created a new scene. We can load that brand new scene up. So we just have a blank scene now, and I'm going to delete the other one. I don't really care about the other one. We're not going to use it at all. If you want to, you can delete the other materials, and you can delete the example assets folder. Like we don't need that. Those are the assets that were in that other scene. So you can delete the example assets folder if you want to. There's nothing in there that we need. This is why I don't like starting with a URP or HDRP project, because they have all this stuff. I wish they just had a blank project for you, but that's the way that they've decided to do it. So in this scene, all we have is the main camera and a directional light. We're going to make one change to the main camera. Right now, there's a skybox. So if I'm in game mode, I see the sort of skybox here. I got my sort of horizon and the blue sky. I don't want that for what we're going to be doing. I want just a blank, just basically a blank color. So selecting on the camera, in the camera component, down in environment, there's a background type, and we can change that from skybox to solid color. And of course, you can change the color to whatever you want. I'll just leave it as sort of the default blue. Give me some problems here with one of the GUI things, probably related to something that I deleted, so we could probably get rid of a few other things in here as well. This is why I don't necessarily like this, because there's all the settings and stuff that they already bring in there for you. So I can probably get rid of the tutorial stuff here. I might just delete the README. This is Yeah, this is why I don't like starting with just a standard one here. All right, we'll see if that error keeps popping up. If it does, we'll delete it. We'll delete some more stuff. Okay, so I have the solid color background. So now I don't have to worry about any sort of skybox interfering with any of the view of the post-processing that we're going to see. I'm going to create a 3D object, and it's just going to be a sphere. So it's just going to be your basic sphere. If I go into game mode, looks like this. I'll probably move it around a little bit. Let's set it to 0, 0, 0, and maybe move it a little bit, move the camera a little bit closer or something. Like this, and I'm going to set the camera to 0, 0, 0 as well, and just move the camera back a little bit so I get it sort of nicely in my view here. So looks fine, looks like a sphere. I should probably have a material for this so I can change the color of it. So in the materials folder, I'm going to create a material, and I'll just name this sphere. And the standard universal render pipeline lit material is fine. So it will be affected by our lights. And I can mess around with stuff in here. So my base map, I can select a color, and that will be the color of the sphere once I apply it to the sphere. So let's say I want a red sphere. So I change the color. In my sphere object, element 0, for the materials, I'm going to take my sphere material and put it in there. So now I've got a red sphere. So this is just getting stuff set up. I got a material that I created, just a standard material that I created, changed the color on the base map, and then essentially dragged it into the sphere. So I've got my color. We're going to mess around with this a little bit, the material, just a little bit later on. But for now, this is this will work for what we want to do. Now comes the post-processing part. Typically, what I do for post-processing is I create an empty, and I rename it post-processing. Post-processing in Unity deals with volumes. You have a volume where post-processing is active. If your camera is in that volume, then you get a post-processing effect, whatever you set up. So I'm going to add a component to this empty game object I just created. And I want I already have a search for here. I want the volume component. Get the volume component on my post-processing object. The reason why I create an empty is just so if I want to make some changes to the post-processing, I know which object I want to use. I know which one I should go to. So you could add this volume to whatever. I could add this volume to the sphere or to the camera, or to the light if I wanted to. But then I'd have to remember, wait, where was the post-processing volume at? So that's why I put it here. Right now, the mode is set to global. So it affects everything. There really is no volume. The volume is the whole scene. That's what global means. We will look at local volumes a little bit later. So the other option is local. The weight is something we'll mess around with a little bit later as well, and so is a priority. So we'll just leave those the same for now. The profile, there's nothing in here. And because we started with a scene that already had stuff in it, there actually already is a profile created, but we're not going to use that one. We're going to click on New. That creates, in my Scenes folder, it creates a new folder with the same name as my current scene. And in here is the post-processing profile. Nice thing about this is that we don't have to mess with it. I can still use my post-processing object. So this says this volume profile contains no overrides. Typically, there is a default post-processing, which is usually off. It depends on what you load up, for instance. So if you load up HDRP, the HDRP project, it has a bunch of stuff enabled by default. So overrides will override the default behavior of whatever the scene is set up for by default. Typically in the URP, everything is off, although we'd have to go look and try to find the settings and stuff in here that has it in there. So the default for some of this is using HDR, and this one, the default, at least for the sample scene, is to have a few things on. So we're not using the sample scene one, so we don't have to worry about it. We can add our overrides in, assuming everything else is off. So if I click Add Override, the only overrides I have are post-processing overrides, and then I have all of these options. Bloom, chromatic aberration, color adjustments, depth of field, lens distortions, motion blur, tone mapping, vignette, a bunch of options that you've probably seen in like something like Photoshop. You can mess around with shadows, midtones, and highlights in Photoshop. You can mess around with white balance. You can add a vignette. You can mess around with you can do color adjustments and color curves. So a lot of this stuff is that sort of artistic things that you can do in a regular photo, because in the end, when you render an image to the screen, it is basically just a photo. And so most of those adjustments you can actually do, which is quite cool. So let's add bloom. So as soon as I add bloom, it puts a bunch of these options. None of them are activated. So the bloom is sort of active, but the individual pieces aren't. For a regular bloom, typically you're going to use threshold and intensity, and that'll be it. I'll show you what some of the other ones do, but typically you're going to use threshold and intensity. Now, if I go into my game mode and I take the intensity, which is 0, and I start cranking the intensity up, there's nothing happening. Nothing changes. Not quite what we're looking for. So there's a little bit more we have to do. All right, so Nick, how did I get to post-processing? Yeah, so all I did was I created an empty object. So just an empty post-processing. I renamed it post-processing, but I just created an empty, and I added a volume component to it. So add component, volume. And then in here, in the volume component, it doesn't have the bloom in it to start with. In the volume component, I created a new profile. I clicked on the new button over here. And so then I could say add override, post-processing, and put in things, whatever I need to put in. Notice how bloom isn't on the list anymore. That's because I already have it here. So I clicked on bloom to add it to the list, and then we can activate individual parts or individual pieces of the bloom. So nothing's going on with this intensity. That's because it does depend on the camera as well. So if I go to my camera, I need to allow post-processing. So this says rendering under my camera. It says rendering. Post-processing, I need to check that. You have to do that. Otherwise, the camera won't respect the post-processing that you're trying to do. It can make it useful for maybe you don't want to spend the time. Maybe your post-processing is all set up and you're trying to quickly do things. You turn the post-processing off. You know it's going to look good when it's on, but you want to turn it off because you're trying to quickly figure out if your game mechanic is working. That's one reason why they have this in here, so that if you don't need it, you don't have to spend the time actually doing the extra performance hit when you're trying to debug your game, for instance. All right, so with the camera having post-processing enabled, we can go back to the intensity and we can mess around with it. And notice how it is actually doing something now. So I crank that intensity way up. The bloom kind of looks dumb, but it is doing something, which is good. We are getting post-processing. And one of the nice things about the game view, because we're not running the game right now. We're not running. The game view still shows most post-processing. You're not going to see things like motion blur, obviously, if you're not moving stuff around, but it will show most post-processing. So that might look okay. Might not look exactly great, but that is our bloom here based on that specular highlight. So we have the light coming in, and the light is sort of giving us that little specular highlight where the light is directly hitting our sphere. So we get this little sort of bloom. It looks a little weird, but that's something that we're going to put up with, at least for the moment. So I'm going to put the intensity maybe to like 10 or something. Barely see a little bit of glowiness. For our sphere, though, I'm going to mess with the material a little bit. If you want to see more bloom, in the URP, you're typically going to want to mess with emission. Because bloom messes with, or at least reads from, an HDR color. And if we look at the base map, this red color, there is no HDR color going on here. There's no intensity. Remember when we were messing around with some of our other color stuff, and you could like choose this intensity thing and sort of up the intensity? There is nothing like that for the base map. So that's where we want to mess with the emission. So down here in our shader, and this is something, if you make your own custom shader or whatever, you just multiply the color by a value, and that's the intensity. So you're in your own custom shaders and shader graph, intensity is just something that you can just multiply the color by. But in our standard sort of lit URP shader, we have to turn on emission, and then we have the ability to have an HDR color. So let's say I want the emission to be red. I can turn up the emission, and now it's a little bit too high, looks pretty dumb, but that's how I can really get some glow on this thing. Now, to me, this glow looks not great. It's not until we get like up here that it's okay. We're gonna fix that in just a moment. So let's say we want the intensity to be 2. Say I put 2 for the intensity. We get this weird sort of outline. It doesn't look all that great. But this is just regular bloom with some emission as an HDR color. So a red with a certain amount of intensity. HDR colors are very difficult for your monitor to deal with. Monitors are not HDR. Monitors are LDR, low dynamic range. Whereas I'm trying to display HDR colors. It's basically, if your monitor can display like 8-bit colors, you're trying to do something with a 16-bit color. Your monitor can't display it. So what does it do? You can change the default behavior. This is typically what you want to do if you have bloom. If you don't remember anything else from the lecture today, if you want to use bloom in post-processing, always do a tone mapping. Always. So we're going to add an override. Post-processing override. So I'm back in my post-processing object, and I'm going to go down to tone mapping. And we're going to select mode. There's only one option here. Currently, it's set to none. We're going to do aces. So this maps those high dynamic range tones to something that your monitor is sort of able to display, and it actually makes it look good. This looks way better in terms of sort of a glowy bloom color than something like either neutral or none. Aces is I think it's like Academy. I have it in the slides. It's like Academy something or other color something. I don't remember. We'll look at the slides again here in a second. This is used in video games. This is used in film to record stuff in HDR in, say, on a camera, or do stuff in HDR in a game, and then tone map it back to something that a monitor that you have is actually going to be able to display and have it look nice. So now I can drop this intensity down. Let's say I want to drop it down a little bit, just have a little slight glow here on my sphere. So this type of bloom plus tone mapping plus a little bit of emission is what you want for, let's say you're making sparks, or you're making a laser beam, or you want to have a little bit of glow around a sort of a light or something in your scene, like I don't know, like a fluorescent light tube or something in your scene. You make it emit some white light, and then add a little bit of bloom along with the aces on it, and then the aces tone mapping, and then you're good. You have a nice bloom on your light. So this is if you don't remember, like I said, if you don't remember anything else from this lecture, if bloom, which is quite useful for a lot of games, throw in aces tone mapping and you'll be good to go. It's actually going to look good. The other options here, things like scatter. We can adjust the scatter. That's going to adjust the actual bloom itself, how much scatter the bloom is going to how much scatter in sort of the atmosphere. So you can sort of make it look a little bit more sort of foggy-ish with the bloom. Typically, the standard value of 0.7 is probably going to be fine, but if you want it to be a little bit less, the bloom to have a less extent, then a lower value might be something that you want. but 0.7 tends to work okay. But again, these are things that you can just go and play with. You can tint the bloom if you want to. So here we can tint the bloom red or potentially different colors. Depending on the colors that you pick and the color that your emission is, you might get some weird stuff that kind of looks like this. So typically you just keep the bloom at white and you don't even worry about doing the tint because you want it to tint the emission color. You want the tint to be the emission color. So the emission color is already color, so you leave the bloom as being white, and then it'll just sort of transfer that emission color on there. So Nick, how'd you make the base map a HDR color? So that's where I left the base map the same, and we went down and activated emission. So we have our emission color, and then we increase the intensity from here. And of course, you can mess around with this so as much as you want. So maybe I want 2 for the intensity or something. So yeah, so we mess with the emission. So that's the key to getting an HDR color so that your bloom is going to look good. But even if we don't put a emission color on it and we mess around with the intensity some more, you do get some bloom from that specular highlight. But if you want the whole sphere to glow, that's where you got to have the emission there. And usually you got to turn this up real high on that specular color in order to get it to sort of look halfway decent. So in the URP, it's this emission color that's going to do it for you. So I'll turn that up a little bit. There we go. There's a few things here for like clamp and stuff like that, but typically we don't have to worry about it. There's one that's going to give you a little bit more like a different filter on it, sort of high quality filter. You can look and see if it gives you a difference. Typically, I don't see much difference with the high quality filtering. We don't have a texture to add for lens dirt, but if you wanted to sort of simulate that your camera has a dirty lens, so say you have a game where you're driving through some mud or something, that's something where you could add a quick dirt texture when there's dirt on the lens or something, and it'll sort of dirty up what the bloom looks like as well, since bloom is typically a camera-related phenomenon, not something that is physical. If something is very bright, it's not All right, well, let's see if I can figure out what's going on before Thursday then. He keeps kicking me out here. I'm reopening up the project here as well. Get the folder set up. Okay, so while Unity is sort of opening up here for the project, again, looks like I didn't save what was going on. So let's go ahead and remake the ball and the post-processing piece. A lot of this stuff is in the slides here. So showing things like making a new post-processing profile, adding overrides in. We're doing global for the moment. There's a material that we had to create stuff with the bloom and the scatter and all that kind of stuff, and being able to add post-processing on the camera. So to get to that sort of glowy looking effect. Doing stuff with the emission, so we get this nice sort of real sort of glowy bloom, and the tone mapping. Yes, this is Academy Color Encoding System. So that's the one you want to use when you're working in HDR. Just do tone mapping, because it's going to make everything look quite a bit better. So we get this nice sort of glowy bloom here. So let me go back through and make a couple of these things again. So change the name, add a volume, add a new volume here, and I'll put bloom back on, and I'll put the tone mapping back on as well. Okay, so I got the tone mapping there. Aces, we'll throw the threshold and the intensity on, turn this up a little bit, and add a quick sphere. Zero it out. This time I'll save the scene as well. Zero you out and move you back a little bit. Getting us back to a solid color, turning on post-processing, and put my material back on. So we get our nice ball again here. And this will be the. It's possible that I already have all this stuff in there, but I don't know if I saved it after that. So let's just call this something different. Okay, so that's our sort of bloom thing. Let's take a look at one of these other ones. So something like film grain. Right? So we got film grain. We can turn on the type, the intensity, and the response. Film grain is something that obviously, if you sort of have like an older camera or an older sort of video recorder thing, you might see some grain in some graininess. You've sort of heard that term before. So we can get that in our actual camera as well. So we can. This might be tough to see on my screen, but you can see this sort of graininess, and it's kind of moving. Like depending on what you sort of click on, you'll see it sort of change every once in a while. So if I run in game mode, it might be tough to see from the screen share, but you get this sort of graininess that's changing over time. And if we change the type of grain, so the type here, it's thin one, maybe if we change it to like large, now you can probably at least see it a little bit in the still, and in here you might be able to see it a little bit better. So it gives you sort of a film graininess effect. And again, that's just an image processing technique that you can apply after everything's been rendered. So is it useful for most games? Probably not. But it's something that if you want to add a little bit, and that's one of the keys here in post-processing, is a little bit goes a long way. This is probably not going to do it for most games. But if you want a little bit of that film grain aesthetic, you turn the intensity down to quite small. So it's not very intense. And you see how it looks. I can barely notice anything at all, but there's a little bit there. So a little bit for these post-processing techniques does go a long way when it comes to these different types of effects that really potentially can change your images. I think, yeah, so I had the film grain one, so you can mess around with that. I had a little visual here. Like I said, if you overdo it, the visuals will likely look worse. Vignette is another one that might be interesting. So if we come in here, we add a vignette down at the bottom. We can mess around with a few of the pieces here, and intensity is usually the one to mess with first. You can see what this sort of vignetting looks like here. Sort of comes in from the corners. It actually would represent something like you have maybe like a telephoto lens or something, and the light coming in, and this is why having just a little bit of vignetting like this, where it's darker around the corners. This darkness comes from the fact that your sensor or your film is large, like a large sort of area, where it's actually the lens itself is actually interfering with the light that's coming in. So yes, so you get this sort of circular pattern, circular sort of distortion on your square lens. This happens to me. So the camera that I use for sort of face stuff is a Canon 6D Mark II. So it's a full frame camera, like 24 something megapixels. When I connect my camera up to my telescope, I have an 8-inch Smith Cassegrain telescope. When I do astrophotography stuff with it, so things like galaxies, nebula, and stuff, I get vignetting because I have this 8-inch aperture, the 28-inch aperture, it's around 2,000 millimeter focal length, and I have a square sensor attached to it, and the telescope is circular. So I get exactly this. I get vignetting in my images. So I get something that kind of looks like this. It might be a little bit less intense than this, but I do get darkening around the corners because of that mismatch between a square sensor or a square film and the circular aperture that I'm using to capture that picture. So from a realism standpoint, this might happen in using an actual camera, but you can also imagine doing non-realistic stuff with this. So we can mess around with things like the smoothing. We can have these totally round if you want to, so it's not based on your aspect ratio. You can change the center position on this as well. So you could do some interesting things with this that are not really related to a physical sort of sensor type thing, but having something where maybe if you want to make it look like somebody's vision is sort of going out before it fades all to black, just increasing the intensity of the vignette is something you could do to help you get there. So there's a lot of stuff you can do that's not necessarily related to camera type things with these. So vignette, it's just another tool in your post-processing toolbox. And then, yeah, you can mess around with the options. I think there was the color there. So, yeah, so if you want a different color, you can always throw a different color in there for the vignette as well. Yeah, so here's sort of an example of that vignette plus the other features that we had thrown in. If you've messed around with a lot of sort of 2D software for Photoshop type stuff, shadows, midtones, and highlights are probably going to be sort of familiar to you. They let you change the intensity of colors in different tones that you render. So a shadow tone would be the colors of your shadows. Black is still going to be there, but maybe if it's in partial shadow, maybe you want it to look more like a particular color. The sphere that we're using isn't the greatest for this, but you'll still be able to see stuff. So there's a lot of adjustments here. You can mess around with the highlights. So that'd be like the specular colors or the midtones, the sort of midway between super bright and super dark. You can mess around with those as well. A lot of times in video games, you make slightly blue shadows. Rather than having deep black shadows, you make slightly blue shadows. And in the daytime, that should make sense because the sky is blue, at least if it's clear out. The sky is blue, so you get some of that extra light from the blue sky, so your shadows are not completely black. They're going to look a little bit bluish because there's a little bit of blue light from the sky that's interacting with them. This would be something that, for example, ray tracing would be able to solve, but in URP, we certainly don't have ray tracing. In HDRP, I'll show you that there are options for it, although I've never actually played around with it. So you might have very black shadows at night, but during the day, you might want your shadows to be sort of bluish. So what I can do in here, if I add an override in, and we might actually turn off bloom and maybe the tone mapping too, just to get back to maybe no emission. So something that looks more like this. Maybe I'll have it be a little bit grayish or something, just to get back to sort of a more regular looking sphere without any extra post-processing on it. If I do open up shadows, midtones, and highlights, I end up with a situation like this. And this allows me to change the color and the intensity that the shadows and the midtones and the highlights are going to have. So if I click on shadows and I drag this over to be a little more blue, it considers the background to be a bit shadow as well because it is darker. So that's why it sort of adjusts that as well. But you can see in here, and I've done this is pretty extreme, but you can see that the shadow here, not the part that's completely black, but the actual other piece of the shadow here has become somewhat blue. So being able to adjust these sorts of things can be useful. And again, a subtle effect is going to do a lot more good than something that is sort of way way too intense. The little slider down at the bottom allows you to mess with the intensity of the shadows as well. So make the shadows much brighter, make the shadows much darker. It's just an intensity thing. But the color lets you mess around with this. So if I take the midtones, I turn the midtones on here for me to change. Maybe I want the midtones to look a bit more red. So this is much more midtones up here. So they just let you mess around with the actual coloring and the coloring of the shadows, midtones, and highlights to get it where you want. And this is how you get some of those sort of atmospheric games as well, where stuff is they've done some sort of color correction or messed around with the colors of say just the highlights or just the shadows or something. This is how you can make some of those types of effects. So it's just another option that if you're sort of used to messing around with some of these things in something like Photoshop, you have a lot of these same options for post-processing effects. Depth of field is also one that is easy to add in. URP lets you mess around with this in a non-physical way. You basically choose the start and the end of where your focal plane actually is. So it's not based on real camera settings. In the HDRP, it is. HDRP, it's like all like realistic camera stuff. But in the URP, you choose where you want your focal plane to be. It's very easy to make depth of field look really strange. So that's something to be careful with. But just remember that for depth of field, anything too close from the start is going to be blurred out. Anything that's too far from the end is also going to be blurred out. So it gives you this depth of field where you have something in focus, everything else not in focus, or some range in focus and everything else not in focus. So if you have some sort of cinematic or something and you want to make it so that a person's face is in focus and I don't know, whatever, a tree or something that's close to the camera is out of focus, this is a very easy way to do that. With our sphere, it's not going to be too obvious what's going on because we only have one object in the scene, but you can certainly mess around with this. If you put a bunch of objects into the scene, you can certainly mess around with the post-processing depth of field. And really the mode here is just saying how it's blurring it. So using a Gaussian blur, for instance. And that's something that if you do stuff in an image processing class, I can do a little bit of this in CS2, but not necessarily Gaussian blur. That's just using a specific type of blur to blur out the stuff that's not within the focal plane. So if you want depth of field, you just slap it in there, pick the start and the end. These are in like unity units. Pick the start and the end, and that's where stuff is in focus. And then there's a couple other things for like radii and high quality sampling if you want to take a little bit more time to do the calculations. Okay, so that's just a few of them. There are lots more. You can go in and mess around with them. Some of them are pretty straightforward. Things like white balancing, so we can change what the white color actually is. This can make it so if you want stuff to look a little colder or a little warmer, this is an easy way to do it as well. And of course, there's tinting of this as well. So if you want to sort of tint or change what the white color is, you can always do that as well. There's lots of them in there to mess with. All right, so one of the last things that I want to talk about URP-wise is the local post-processing volume. So in our picture here, you can see a collider. This is just a box collider. The one that we created was global, so it affects the entire scene, but a local volume only affects a small portion of the scene, what's inside of a specific collider. So in my volume here, I'm going to change this to local. And let's turn back on like bloom and tone mapping and film grain and vignette. Let's turn on a whole bunch of these things. I'm going to remove the other one from it. So we have sort of all the ones that we were messing with before. As soon as I change it to local, it says add a collider to this game object to set boundaries for the local volume. So I need a collider. So I'm going to shrink all these down and I'm going to add components. Let's add a box collider. So back in my scene mode, there's my box collider. So if my camera is within this collider, I will see the post-processing effects. So let's adjust the collider dimensions here. And let's make it a little bit wider this way and a little bit wider this way. And just so when I add that movement script in, my camera is going to pass into this. And I'm going to move it just so it covers about half of this ball here of my sphere. Maybe like this. So something like that should be fine. We're going to add the little movement script on here in just a second. And in my sphere material, I'm going to turn the emission back on. So we see all the glow and all that stuff. So if I go to my game view, I don't see any of the post-processing things. But from the place that had the slides, let me grab find where I downloaded that. I have the movement script. So I'm going to take that and I'm going to put it in my script. Put it in my script folder. So you can just download it and just drag it right in. And I'm going to add this little movement script. Once it does a compile here, I'm going to add this to my main camera. So my main camera should now be able to move when I press left or right. It doesn't do anything else. It just left and right. So I move into the volume and I get the post-processing. I move out of the volume and I don't have the post-processing. If I had a global post-processing volume somewhere, then I would get the global version out here and I would get this version in here. So again, I just grab that movement script, put it on my main camera so I can move left and right. And my post-processing volume, now my local volume, is right here. So my post-processing object has a box collider that I've made this size here. So that's what a local post-processing volume is. Let's say you want to have the user, let's say you're playing a scary game or something. Halloween was just recently. You're playing a scary game and you want them to move into this area where everything gets super dark. So like they step into a room and everything gets super dark right away. You don't necessarily have to change the lighting for that. You can do some post-processing to change how your tone mapping is working or change your exposure, change some of these other post-processing features that can give you this effect. Maybe it's just for like a quick jump scare or something. Everything gets real sort of dark, like the person's passing out, and then all of a sudden, something happens. Play some sounds, do whatever. That's what you can do with this sort of thing. You move into a particular area, you get a different set of post-processing. Now, it's very abrupt. I'm outside and then all of a sudden I'm inside and I get all of my post-processing. That's what the weight is for and the blend distance. So if we do something like this, we do like a blend distance here. So let's put the blend distance to like 2 or something. And then we go. Actually, weight probably isn't as much as a part of this. We do this here. Now, as we move away, and actually let's lower the blend distance a little bit more, just so we can see it without having to rotate the camera. As I move further away, it sort of slowly comes in to the full post-processing volume, to those full settings. So the blend distance lets you blend from whatever you were to the new value. So the longer the blend distance, the more gradual this blend is going to be. So it's not a big, harsh, instant change. It's a little change over a certain distance. So that's a sort of blend distance thing that you want to probably have if you have local volumes that are sort of touching each other or something, or global to a local volume, you probably want some blend distance on there. In addition, the priority is something that you can set. So if you have multiple local volumes overlapping each other, you can set which one gets priority. So that's what priority does. So you might have in a game, you might have multiple local volumes in different locations. There might be some overlap. Which one do you want to prioritize in any sort of given situation? So don't be afraid of the local volume. It's reasonable to have something like this for a specific effect, or during a cinematic or something. Maybe you want to change what the post-processing is happening as the camera moves through a cinematic. Who knows? For most of your games, these simple games, just a single global volume is probably going to be all you need, especially if all you'd have to worry about is something like bloom and tone mapping. But if you have extra features that you want and they only need to be in a specific area, then definitely throw in some local volumes and use them, because they can be really, really useful for doing certain types of effects. So that's pretty much it. That's basically what I had for the slides in here for the blending and stuff. And the other values, weight. When you have adjacent volumes, that's where you use weight and priority. So weight sort of goes with this as well, but really when you only have a couple volumes, they just help you determine what takes precedence during the actual blend itself. So that's something to mess around with. HDRP is almost the same. I don't have sort of a project sort of ready for you guys for this. I can open up. Like a shader. Let's see. I have one here. I don't see the shader one. Potentially. Trying to think of which one would be easier to mess with. I thought I had the shader one in here. Yeah, let's grab this one. And I'll this one open real quick, but it's basically the same thing. You still use volumes, you still use overrides, you do all sort of the normal stuff that you do in URP. It's just there's more options. So more settings like screen space ambient occlusion, screen space reflections, volumetric fog, different types of anti-aliasing. It's essentially the post-processing for more high-end systems. So we're talking consoles, we're talking desktop computers with dedicated graphics card, that sort of stuff. Something that's going to be a little bit more high end that you don't have to worry as much about performance for this stuff. Things like ambient occlusion are very important. If you think of a 3D model, the sort of nooks and crannies, the lighting is going to affect those the same. So it's not going to look like it's darker in nooks or crannies. But with screen space ambient occlusion, it adds this sort of darkness, as in the model is occluding itself. This is sort of ambient occlusion from the model. And so you get sort of darker areas in your 3D model where you would be blocking light. So, you hear a lot these days about sort of ray tracing stuff. A lot of these techniques, screen space reflections, ambient occlusion, all of those are what came about because we couldn't do ray tracing in real time. So all these little tricks are things that you can add to your scenes as well. Let's see if this one's open here. Yeah, so I can do the same sort of thing here. I can create an empty and let's name it post-processing. And I can add a volume to this. And I can make a new post-processing profile, and then I can add things to it. So there is some ray tracing in here. So there are things I haven't messed with this. So and these are all preview. So they're all like preview packages. So they're not sort of fully finished yet. So that's something you can mess around with if you want to. There's other stuff here like fog. So I can have a volume that is a fog volume. So I have more options than I had in the URP. I could add some different lighting stuff. So here's some ambient occlusion, for example, screen space reflections and refractions, stuff like that. And then there's some of your regular post-processing that you saw in the URP. So you have your bloom and your depth of field and your film grain and all of those as well. But you have more options here, things for like messing around with shadows and stuff, than you do in the URP. So if you want that sort of high-end look, then the HDRP is what you want to go for. It loads up just like the URP. It's going to have all that sort of initial stuff to look at, like that initial scene and things, and you can delete those as well. A lot of times when folks mess around with Unreal Engine, for example, they're like, oh, wow, Unreal Engine, the graphics here are so good. Part of the reason is because a lot of these post-processing things are already enabled. So things like ambient occlusion and volumetric lightings and fog and all that stuff is already sort of on and enabled and ready for you to use right away. So Unity has those things. They're just not enabled for you right away unless you specifically go in and do that. So if you want that sort of higher end stuff, then feel free to go in here and start messing around with some of the ray tracing preview things or the sort of ambient occlusion stuff if you want to mess with it. Ambient occlusion is one of the biggest things, especially when you have complex models. So just like a little bit of bloom and tone mapping is something you probably always want to add into your games, ambient occlusion is typically one you want to have in there as well. And if you have like mirrors or water or something, things like screen space reflection and refraction are good things to have in there as well. It'll make your water look better. It'll make it like a mirror look better, for example. So I just wanted to give you sort of a light look at this to show you that it was basically the same as with URP. It's just more options to it. You still have local and global volumes. You still have your post-processing profile. You still have all the normal stuff. It's just more possibilities for you. All right, so there is some good resources. This is just a couple of them. Some of these are sort of directly from Unity. So how post-processing saved the day, an introduction to the post-processing stack. This is the HDRP version, and then one that's with URP. So sort of the two versions of them. For your final project, the Game Jam style project, I do recommend using the Universal Render Pipeline. You can use HDRP too, that's perfectly fine, but I recommend at least using the URP because then you have access to these things in a very easy way. The regular 3D Unity project has access to this too, but it's a bit different. And to be honest, I basically haven't done it that way in years, so I don't remember all the entire process for it because I mostly use the URP, especially if I want to make like a game that I can put up on the web, for instance. So I mostly use URP, but the HDRP is about the same. So if you want to look at some of these are from Unity Learn, and this one's from Unity Connect. If you want to look a little bit more of these, that shows you sort of all of what each of the individual post-processing sort of elements does. These will sort of get you there, and you can take a look at them. So don't be afraid of post-processing. It can do some really cool stuff, and most of the time it doesn't cost a lot. So Bloom doesn't really cost too much to do, and you can do it on the web and stuff without too much trouble. So that is it. That's all I have for today. We're going to talk about importing art assets, both 2D and 3D next time, and then after that, we will get started on our next game, on our final game. I may give the second. I don't know. I haven't decided yet. I might give the second GDD on Thursday, either that or it'll be the week after. I might just make it the week after. It'll just be another similar sort of thing, but I'll give you a different theme. I already have a theme that I want to use because I've made a game using that theme before. So I'll let you know what that is when we get the assignment. So otherwise, that's it. So I will see you guys on Thursday.
Thank you, Professor.
Thanks, Professor. Yeah. Have a good one.
Thank you, Professor.